Hello and welcome back. This is Dr. Me at the Actuarial Academy, and we're getting ready to work a very common joint random variable problem. We have x and y. They're discrete random variables with the following joint PMF. Okay, PMF stands for probability mass function, and so we should be at the level where we understand what this is. This describes jointly how y and x are distributed. So the probability that y equals 0 and the probability that x is equal to 1 is equal to 0.4. The probability that both are 0 is 0, so forth. We can actually see that the sum of all these probabilities equals 1. And so we're interested in finding the variance of y minus x. So before we actually tackle this problem, I'd like to review fact, something you need to know, something you need to have memorized before you start this problem, and that is for any random variable z, the variance can be computed by taking the expected value of z squared minus the expected value of z squared. So this is called the shortcut formula. Typically that's how it's presented in probability and stats classes. And so this is something that is a must memorize fact. And so to work this problem, we determine what values y minus x can actually take on, all possible values. And then once we have that, then we can compute its expected value. This piece, okay, because we can think of y minus x as actually equaling another variable, z. And then we need to determine all the values that y minus x squared can take on, and then compute its expected value and basically just apply this formula here. So let's start out with doing a little table. Let's go ahead and think of z is equaling y minus x. And we'll construct a little table here. And z can take on the values, well, let's look. So z is defined as y minus x. That's what we're trying to find the variance of. 0 minus 0, 0. So it can't take on the value 0 because that's with probability 0. But it can take on the value 0 minus 1, which is equal to negative 1. Let's go ahead and write that down, negative 1. Likewise, it can take on the value 0 minus 2. So really just going down the chart here. It really doesn't have to be any particular order. And then 1 minus 0, so it can take on the value 1, probably 0.2. We'll write that down in a moment. And then it can also take on the value 0. Actually, I was wrong when I said it can't take on the value 0. Actually, it can. So it can take on the value 0. It's just that they both can't take on the value 0. And then we can also take on the value of negative 1, 1 minus 2. And then, no, actually that occurs with probability 0. So these are all the values that z, or y minus x, can take on. I'm doing work here to be able to compute expected value of z. So I need to know what the probability of z is. And then from this we will be able to get the expected value. So the probability that z takes on negative 1 is equal to, the only way it can take on negative 1 is 0 minus 1, and that's 0.4. So this occurs with probability 0.4. And it can take on negative 2, likewise with probability 0.2. And it can take on the value 1 with probability 0.2. And then the probability takes on 0. You can convince yourself that's 0.2 as well. So as a check, make sure this sums to 1. It does sum to 1, so that's good. So now we could actually compute the expected value of z, and let's actually wait before we do that. We could do it now, but we're on a roll here. We now would like to look at, and let me just draw a little line here, z squared. And again, z squared is our 1 minus x squared. We're trying to find the variance of this, so we need 1 minus x squared. And so z squared, you can literally get that just from here. You already have the values that z can take on. So z squared then can take on values derived from just squaring z. So we see negative 1 here and 1. So this can take on 1. It can also take on 4. Again, this doesn't have to be in any particular order. And 0. So we get 4 from squaring negative 2. The only way to get 4, square 0, get 0. And now we need to know probability of z squared. Okay. We've actually already done the work for this. In order to get 1, z could either be -1 or 1, so the probability here is 0.6. Okay, I'm just summing up 0.4, 0.2, because that's the only way to get 1. And likewise here, to get 4, you need to square -2. That occurs at probably 0.2. And the only way to get 0 is by having 0, z equals 0. So this is just 0.2 as well. Very nice. So here's our table that we're going to use. And now we're going to apply the formula. Let's just go ahead and separate this out. Let's do the expected value of z first, since we did that here first. Okay, you should know how to compute the expected value of z. It's a standard formula. Take the value times the associated probability. So it's -1 times 0.4 plus a -2 times 0.2. So I'll just write that as -2 times 0.2. And then plus just 1 times 0.2, which is equal to -0.6. And now we need the expected value of z squared, and we do it in a similar fashion. Take our value times associated probability times 0.2, and then 0. We don't need 0. I get zeroed out anyway, so, and this is equal to 1.4, 0.8 plus 0.6. And we're almost done. Now we apply the formula given over here by fact. So the variance then is equal to, it's just the expected value of z squared minus the expected value of z quantity squared, which is equal to 1.4 minus -0.6 squared, which is equal to 1.04 if I did the arithmetic correctly. And that's our final answer. So, thank you very much.